Okay, we have a point A. We have a line, 2x plus y equals 3. And we want to find some point over here on this side of the line such that the line here is the perpendicular bisector of the segment connecting A and the other point. So you'll remember that perpendicular bisector, it cuts through the middle of a segment and it is perpendicular to that segment. So what we're looking for is if we were to travel from A up to the line, straight to the line, perpendicular to the line, and then cross it and go the same distance on the other side, that's where our point's going to be. Okay. So what we're going to do first is we're going to find, we're going to find a line that's kind of perpendicular going through here. And remember, perpendicular means slopes are negative reciprocals. So let's write the equation of that line. By the way, to graph this was just a real simple y equals, and just subtract 2x from each side, so 2x plus 3. Okay. So the slope of this line is negative 2. So the slope of our new line will be positive 1/2. So we've got our equation for, we'll call this, whatever. We've got y equals mx minus h plus k, where m is the slope and hk is a point that the line goes through. In fact, there's the point right there. So y equals, our slope is going to be, remember, positive 1/2, because that's the negative reciprocal of negative 2. You can think of negative 2 as negative 2 over 1, and flip it upside down and change the sign, you get 1/2. X minus, so it's going to be a minus a negative 1, which becomes plus 1, plus 1. We'll do a little distributive property here. Y equals negative 1 or 1/2 x. So it's going to be plus 1/2 plus 1 is going to be plus 3/2. So there's our equation. Okay. So the next thing we want to do is we want to figure out where does that line cross. And we could sketch that line in. It's going to look like this. All right. So we can kind of sketch it in a little bit here. Let's see. Let's go ahead and do that. So there's the line. We want to find where that point of intersection is. Where's that point of intersection so that we can travel up to that point of intersection and then go that much further on the other side. So same distance on the other side. So we have to know where they cross. So we're going to find that point of intersection next. And as usual, we're going to take the x part, the mx plus b part of this equation, and the mx plus b part of this equation. We're going to put them together, say they're equal to each other. And then we're going to solve for x. That'll give us the x coordinate for our point of intersection. And then we're going to take that x value and plug it in to one of the equations, both if we want to be extra sure, and get a y value for our point of intersection. So let's see. We're going to start out with 1/2 x plus 3/2 equals negative 2x plus 3. So there's our two mx plus b portions. Let's see. I'll add 2x to each side. That gives us 5/2 x equals, I'll subtract 3/2 from each side. 3 minus 3/2 is 3/2. And then I'll divide by 5/2 on each side. And here's where I would just bring in my trusty calculator. I would go 3 ABC2 divided by 5 ABC2 gives us 3/5. X equals 3/5. And I always like to go up here and double check. Our point of intersection is between 0 and 1, and it looks like it's closer to 1 for the x value, so I'd say we're right on there. Okay. Next up, we're going to find the y coordinate, so we're going to go back to one of our two equations. Y equals, we'll pick the one over here, negative 2x plus 3. We'll put in our 3/5 here, plus 3. And I'll just get my calculator out and put all that stuff in. So we got negative 2 times 3, ABC5 plus 3 gives us 1 4/5, which is 9/5. 9/5. Let's go take a look up here. So this is, it looks like 9/5, 1 4/5. It's a little bit less than 2. I buy it. That looks about accurate. So we're going to call this the point 3/5, comma 9/5. Okay, so now we want to find a point that is that much further on the other side. Now we could do some like crazy distance formula thing. I'm going to find the distance between these two, and then I'll somehow put that distance. That would be too much, right? We're not worried so much about distance. What I want to think about is what is the vector from here up to the intersection point, and then we'll just double that vector's length. Remember, a vector is just a movement in the coordinate plane, so I want to describe the movement from A up to the intersection point using a vector, and then I'll just double that vector. And when I double it, it's going to mean up to here, and then that much further again, going in the cell, so that doing that same movement twice. So to find a vector, we just have to find what is the displacement from A up to the point of intersection. And to do that, all we have to do is just set up a little table here. X, Y, we're going from -1, 1 to 3/5, 9/5, and we just subtract end minus start equals change. So I'd go 3/5 minus -1, 3/5 minus -1 gives us 1 3/5, which is 8/5, comma 9/5 minus 1. Well, 1 is 5/5, so 9/5 minus 5/5 is 4/5. Okay. And what that means is that to travel from -1, 1 to this point, we travel forward 8/5, so that's forward about between 1 and 2 spaces. If you look, from here it is forward 1 and a portion of a space, 1 3/5 space, and we go up 4/5 of the space, we're going up less than a full space. And if we travel from here to here, you can see we do not go up a full space. We go up a little bit less than a space, right? So this vector describes the movement from point A up to the intersection. Okay? So now we're just going to double that. So 2 times 8/5, 4/5, and this is just kind of like distributive property. We just double the two components, and we end up with 16/5, comma 8/5. Right, so that's the movement from A to, I don't know, what did we call the other point that we're trying to find? B, and we'll call it B. So this is the vector that will take us from A to B, the movement in the plane from A to B. So now we just have to start at A and do that. So we start at point A, and we've got the point -1, 1. And we are going to add 16/5, 8/5. And this notation here isn't anything super standard. I'm just trying to make it make sense here. We're adding these coordinates. So -1 plus 16/5 is 2 1/5, which is 11/5, comma 1 plus 8/5. Well, let's see. 1 is 5/5 plus 8/5 is 13/5. All right. So 11/5, which is a little bit more than 2. So that would put us 1, 2, and just a little bit more. Travel up to the line, 1, 2, and 1/5, right around there. This will be point B. And let's see, the y-coordinate for that point, according to our calculations, should be 13/5. And 13/5 is, what, a little between 2 and 3. Look here, 1, 2. There's 3, it's between 2 and 3. So I'd buy it. 11/5, 13/5. Okay, so that's the point that makes this line the perpendicular bisector of AB. Just to go back over how we found that, we had to first write the equation of a line that passes through point A and is perpendicular to the original line. So the slope of that line would be the negative reciprocal of the original line. We wrote it in point slope form. Then we had to find the point of intersection, right? And we did that by setting the two mx plus b parts of the equations equal to each other. Solve for x. Once you get an x value, you substitute that x value back into one or both if you want to be sure of the two equations to find the y coordinate for the point of intersection. So once we have an x and a y coordinate for the point of intersection, and I always like to go back and kind of look at the graph and see if those x and y coordinates make sense, they look okay, and they did. So once I find those, I want to find what's the vector from A to the point of intersection. What is that movement in the coordinate plane from A to the point of intersection described as a vector? And we just go end minus start equals change to find that vector. And it was 8/5, 4/5, so travel forward 8/5 of the space and up 4/5 spaces. And as soon as we find out what that vector is, well, from A to the point of intersection, we just want to double it and go that much further on the other side. So we just took the original vector, we doubled it, and then we see, well, okay, if we travel by that vector from point A, so we're just adding the vector components to the coordinates for point A, we will get to point B, the point that is the same distance on the other side of the perpendicular bisector and on that perpendicular line. Awesome.